Hey, Math 30-2s, we're going to go over our last worksheet here, financial applications and some other stuff. This one's just pretty easy. If you took this in class, we would have learned how to make these equations. But right now, I'm just going to give you these equations and you just have to apply them. It's pretty easy. So I have here loaded the thing and the graph or my calculator here, so we can show you both at the same time here. So just turn off a few things. I turn off the plot. I'm just going to plug in my equation here. So you can go through and read this. It says Lloyd here arranged a personal loan of $2,500. So that's why there's a $2,500 in the equation. Going up by 10.75 per annum. That just means per year, compounded quarterly. Now, there's a lot of things how these numbers down here, how this relates. So what they do with this number is they divide it by 4. That's where this 2.875 comes from. And because it's quarterly, quarterly stands for 4 times a year. That's where that 4 comes from. And you made no payment for 2 years. Okay. So you just put an amount and then just didn't do anything with it. So let me just type this equation in. There we go. Okay, so now we have this nice equation. It's not going to look very nice in my calculator here. You're not going to see anything actually because just how big this graph is. Just remember, if you remember characteristics, the 2,500 is where it starts on the y-axis. So if I go my window, I want at least my y maximum to be 2,500. Okay, so if I did that, pretty good. But the problem is the graph is a growth graph. So it hits 2,500, then it goes up beyond that point. It's got all this negative time stuff over here. So we can get rid of the negative time. So I'm just going to get rid of the negative x value. I'm going to make this a little bit bigger. So I'm going to go to maybe 5,000. See what that looks like. There we go. So there's a line, starts at 2,500, goes upwards. Looks pretty good. So what is the amount owing at the end of the 2 years here? So 2 years, you can put a 2 in that equation if you want to. You can go, let me just write this out. I can say A is equal to 2,500, 0.02875, 4 to the power 2. I can do that, yeah. Might as well, it's there. You might as well just use the equation as is. So 2,500. You know, I don't know why I'm typing in my calculator there. I have my calculator here. So 2,500. You'll see why we. Actually, I don't know. We'll see. I don't think we need the graph to do this question, but whatever. To the power of 8. So he will owe $3,136. And I don't know, 31 cents, who knows. Okay, but you could have got that from the graph too. Here's my graph. I can just go trace 2, and you get the same number there, 2 being 2 years. Okay, how much interest was he charged, right? Well, to figure out how much interest he was charged for the 2 years of just not paying off his debts here, I'm going to subtract how much he started off with here. And minus the 2,500. He was charged $663 in interest. Cool. Here's another one here. Price of a famous brand name camera can be found by this equation, a nice little growth equation, where C is the circumference of the lens in centimeters, and P is the price. What is the cost if the diameter is 17 centimeters? Oh, this is different. Like, what we have to know is how do we get circumference from diameter? Well, that's just pi times d, right? If you remember that one from, it's 2 pi r or pi d to get my circumference. I'm just going to punch this in my calculator. Actually, I don't know why I can pull out my other calculator when I have this one here. Oh, what did I say my circumference was? Or my diameter was 17. So my circumference of this very specific lens is 53.407 centimeters. So now I can put that into this equation. These are not very hard. Oops, I don't know why I didn't put it into the equation. I'll put it in now. So 14 bracket, wrong bracket, bracket 11, oh, not 11 either, 1.1 bracket, and that answer there. So second minus gets me the answer. So it's going to cost $2,274 for that lens. It's probably pretty good for that lens. Who knows? So I'm just going to sit here and enjoy the beach for a little bit longer. And I will see you in the next video. Bye. I'm stopping my video. Oops.